All right, class, it is time to talk about how to do conversions. And I know this is following up our ChemQuest number 6 about converting units, so you've already seen some of this. So, some notes about conversion factors. Okay. The definition, conversion factors, these are the idea, or use the idea that a quantity can, let the dog out, Joe.
Oh my God.
Sorry about that. That a quantity can usually be expressed in several different ways. So, a good example of this is with money, right? For $1, I can have 4 quarters. I can have 10 dimes. I could have 20 nickels. I could have 100 pennies. All of those are the same amount. That is the idea behind conversion factors, is that you have different ways to express the same amount. An example within the metric system, 1 meter is the same as 10 decimeters, which is the same as 100 centimeters, which is the same as 1,000 millimeters. If I ask maybe an ant to walk a meter, or if I ask an ant to walk 100 centimeters, or if I ask an ant to walk 1,000 millimeters, any which way, I'm always asking the ant to walk the same length. So these are all the same amount. Okay. So we use conversion factors when we have. Okay, we use conversion factors when we have 2 measurements that are equivalent. Okay, and when that is the case, a ratio of the 2 measurements will equal 1. Okay, which is also called unity. So the definition of a conversion factor is a ratio of equivalent measurements. Again, the definition of a conversion factor, it is a ratio of equivalent measurements. In a conversion factor, the measurement in the numerator, or the top, is equivalent or equal to the measurement in the denominator. Okay, or the bottom. And so, again, because those are the same amounts, you're really not multiplying by anything. Example, 100 centimeters is 1 meter, or depending upon where my units are, 1 meter is 100 centimeters. Remember from ChemQuest 6, which one of these two conversion factors we would use would depend upon what number we're starting with and whether it is measured in centimeters or in meters. Conversion factors are useful in solving problems in which given measurements must be expressed in some other unit of measure. The reason that we can use conversion factors, okay, is that when a measurement is multiplied by a conversion factor, the numerical value is generally changed but the actual size of the quantity measured remains the same. Finally, conversion factors are definitions. So they have unlimited significant figures. So meaning that they don't limit the number of significant figures. Dimensional analysis also sometimes referred to as the factor label method, is a way to analyze and solve problems using the units or dimensions. So again, another name for a unit is to call it a dimension, okay, of the measurement. For an example, we want to know how many seconds are in a workday that lasts exactly 8 hours. So again, I realize that some of you would know right away how to do this. So we are asking 8 hours equals how many seconds? So again, we're going to start with our given, which is 8 hours. Well, I think all of us know that a relationship between an hour and a minute. 1 hour is 60 minutes. Because minutes is in our numerator, it has to go in our denominator. So minutes and seconds. 1 minute is 60 seconds. So mathematically, we're going to take 8, multiply it by 60, and multiply it by 60 again. When you do that, you should end up with an answer of 2.88 times 10 to the 4th seconds. So when we're talking about converting between units, dimensional analysis is a powerful tool for solving conversion problems in which a measurement with 1 unit is changed to an equivalent measurement with another unit. So I think that is a good stop to pause. We will pick up in just a moment with example problems in another video.